we continue for the next part. That is for binomial distribution with the random variable x where p is more than 0.5. To answer this question, you cannot read the table because your table gives the value for p less than 0.5. In order to read the table or to use the table, you need to change to binomial distribution with random variable y. Okay? So, when you change to random variable y, p is less than 0.5. Okay? So, the following table will help you to understand. When x is a random variable or x is a binomial distribution with the parameter n and p, so when you change to y is a binomial distribution, n is still the same, but p now you need to change to q. Okay, q is 1 minus p. Okay, so when you change to from x to y, for number 1, when the question asks to find the probability x more than or equal r, there is probability at least r. So when you change to y, there is probability y must less than or equal n minus r. So from r here, when you change to y, you need to n minus r. For number 2, probability at less than or equal r. When you change to y, you will get probability y must change the value for less than to more than or equal. More than or equal n minus r. Okay. What about the third one? Probability x equals to r. Okay. So when the question asks probability x equals to r, when you change to y, it will become probability y equal n minus r. Okay, instead of r, when you change to y, it will become n minus r because we have n trial here. Okay, I hope this table will help you to read the table when p is more than 7. The simplest way is you need to change from x to y. Okay, thank you. Okay, now we move to the next example. If x is a binomial distribution, n is 10, p is 0.6, by using the binomial table, find a probability x more than or equal 3. So take note that your p here is 0.6. 0.6 is more than 0.5. You cannot use table. If you want to use the table, you need to change from x to y. Okay? So what is the answer for A? Okay, so now we continue. A, if x is a binomial distribution, n is 10, p 0.6, we need to change to y. There is y equals to binomial distribution, n equals to 10, and the value for q is 1 minus 0.6, that is 0.4. So A, find the probability x more than or equal 3. Then we change to probability y. For x more than is equivalent to y less than or equal 3. Here we change to 10 minus 3, that is 7. Okay, so probability for y less than or equal 7 can be solved by using the formula that is 1 minus probability y more than or equal 8. Okay, then we use the table for n equals to 10 and p 0.4 and r equals to 8. And the answer is 1 minus 0.0123 and the final answer is 0.9877. Okay, what about B? Find the probability x less than 5 is equivalent to, we change to probability x less than or equal 4. Okay, x less than 5 means 5 is not included, so probability x less than or equal 4. We change to y, that is probability y must more than, change from less than to more than or equal 6. Then we get the value 0.1662. We use the table for y, for n equals to 10, p 0.4, and r equals to 6. Okay, now we continue see. Find the probability x equals to 4. So this is can be, we can change to probability y equals to 6. Then we use the formula probability y more than or equal 6 minus probability y more than or equal 7. So y is a binomial distribution, n equals to 10, p 0.4. So from the table, n equals to 10, p 0.4, r equals to 6, you can get 0.1662. For r equals to 7, 0.0548, and the final answer 0.1114. Okay. D. Probability x more than 1, less than or equal 4. So 1 is not included here, means probability x more than or equal 2, less than or equal 4. So to change to y, take a look at the table. For x equal to 2, y equals to 8. For x equal to 3, y equals to 7. And for y equals to 4, y equals to 6. So this is the 3 value for y, means y must more than 6 but less than, more than or equal 6 but less than or equal 8. Okay, this is how I get this value. So the formula is probability y must more than or equal 6 minus probability y more than or equal 8 is included here, so we must minus 9 here. So use the table, you will get 0.1662 minus 0.0017, that is 0.1645. Okay, we move to the next example. A man sent for application form to apply for shares in the company ABC. If the probability for each form to be successful is 4/5, find the probability that he is successful in 1 application. B, less than 3 application. C, at least 3 application. So from the information we have n equals to 4, p equals to 4/8. Okay, so you have to let first. Let x is the number of application successful. The question asks, then x is a binomial distribution, n equals to 4, p equals to 4/5 or 0.8. Note that 0.8 is more than 0.5. So what we need to do? Yes, we need to change to y. Y is a binomial distribution, n equals to 4, p equals to 0.4. What 0.2? What is 0.2 represent? Okay, 0.2 represent the probability for the application to fail. Okay, so you have to let y is the number of application fail. So p is the probability for the application fail. Okay, so the question asks A, find the probability x equals to 1, mean the number of application is successful is 1. If you want to use the binomial formula, the formula is given as 4c1 times 0.8 to the power of 1, q, that is 0.2 to the power of 3. To make the value of n is 4. And you have the answer is 0.0256. Okay? Okay. If you use the table, turn to page 5. If you use table, we will use y distribution. Okay? Y distribution n equals to 4 and p, the probability for the application fail is 0.2. Okay? So we need to change from successful to fail. So probability x equals to 1 means probability for the application is successful is 1, means probability for the application is fail is 3. Okay, so probability x y more than or equal 3 minus probability y more than or equal 4. That is 0.0272 minus 0.0016. That is 0.0256. Note that these two value is the same. Either use the binomial formula or use the table. Okay. Okay. B. Probability at less than 3 application successful. Okay. So less than 3 means probability at less than or equal to. So when you change to y distribution means probability y must more than or equal to. Then you can read the table directly. Use n equals to 4, p 0.2, and r equals to 2, and the answer is 0.1808. What about C? At least 3 application successful. Probability when you put into the symbol, you can write as P as more than, at least than for more than or equal 3. Okay, we change to Y. To read the table, means probability Y less than or equal 4 minus 3, that is less than or equal 1. Then rewrite to get 1 minus probability Y more than or equal to 1 minus 0.1808, and the answer is 0.8192. Now we continue to find the mean or expected value and variance for a binomial distributions. If X is a binomial distribution, N and P, then the mean or expected value EX or mu is N times P. The variance equals to sigma squared is N times P times Q. Standard deviation sigma is equals to set of N times P times Q. Example, if X is a binomial distribution and the probability is 0.22 and expected value is 11, find the value of N, A, B, find the variance, and C, find the probability X equals to 4. Okay, so EX is N times P equals to 11. N times 0.22 equals to 11. We get N equals to 50. B, variance is N times P times Q. So 50 times 0.22 times Q, that is 0.78. The answer is 8.58. C, probability X equals to 4. We can use the binomial formula. That is 50C4, 0.22 to the power of 4, 0.78 to the power of 46. And the answer is 0.0059. Okay, we continue our last example. Out of all the people in a particular school, 45% go to school by bus. In a random sample of 30 people, calculate A, the mean number of people that go to school by bus. B, the probability that not more than 10 people go to school by bus. Okay, you have to let first. X is the number of people go to school by bus. X is a binomial distribution. N equals to 30. P, the probability go to school by bus is 0.45. The mean is EX or N times P, that is 30 times 0.45, that is 13.5. B, probability at less than or equals 10 is the probability that not more than 10, means less than 10, but don't forget to include 10 here. Okay, so 1 minus probability X more than or equal 11. So by using the table, 1 minus 0.8650, and the answer is 0.135. Okay.
Next, let's look at example 5. In this example, a coin is tossed 40 times. Find the mean and the standard deviation of the number of hits appeared. So here we need to find the mean, which is denoted by EX, and the standard deviation, which is sigma. From the information given, we already know our value of n, which is n equals to 40, since the coin is tossed 40 times. Let's define our x. So, let x be the number of head appeared. Before you solve the problem, you need to identify your x first. So for this example, our x will be the number of head appeared. The formula in finding mean EX is equals to NP. Since this experiment is about a coin, so there are only two faces of a coin, which is whether head or tail. Therefore, probability in getting head will be equals to 1/2, which means that our P is equals to 1/2. Therefore, the mean can be calculated such that 40 times 1/2, and it will be 20. Simple, right? Let's continue for the next part, which is we need to find the standard deviation. The standard deviation is square root NPQ. Here, we already know our Q will be equals to 1/2 as well. Therefore, our sigma will be equals to N is 40, P is 1/2, Q is also 1/2. So just press your calculator and you will get your sigma is 10. The final answer will be equals to 3.1623. And this is the expected value or mean. Don't forget to write the distribution. What is the distribution for this example? So, the distribution for this example will be X distributed to B. Our N is 40 and our P, which is the probability of getting a head, is 1/2. So, firstly, don't forget to define your binomial distribution. Example 6. At the local swimming club, the expected number of members that can swim a mile is 4.5 with variance 3.15. Find the probability that at least 3 members can swim a mile. So from here, we will have EX equals to 4.5, and we also have variance equals to 3.15. Let's define our X first. So let X be the number of members can swim a mile. So this is our definition of X. And then let's rewrite the information that we have, which is EX, also known as NP, is equals to 4.5. And then our variance, which is NPQ, equals to 3.15. So here you can see the first equation and the second equation. We can substitute NP, our mean, in the formula of variance. Therefore, we will write such that 4.5Q equals to 3.15. Therefore, we will have our Q will be equals to 0.7. since we already get our Q, so we can find our P. Our P will be equals to 1 minus Q, which is 1 minus 0.7. So our P will be equals to 0.3. And then the next one, we need to find our N, small letter N, denoted that the number of member. From the equation 1, we have NP equals to 4.5. So, we already have our P here. Just substitute our P 0.3 into the formula and we will get 0.3N equals to 4.5. So, our N will be equals to 15. Let's define our distribution, which is X distributed to binomial. Our N is 15 and our P is 0.3. It is compulsory for you to write this definition because it is your mark. Okay? The question asks you to find the probability that at least 3 members can swim. From these sentences, we will have P X greater than or equals to 3. This is what the question wants you to find. We need to find P X greater than or equals to 3. So, since the inequalities is greater than or equal, which means that we can read from the table, because the table given is for inequalities greater than or equal. So this will be our table. If you can see, first of all, you need to know your N. So here is your N. N is equals to 15, right? And then your R. Your R is equals to 3. So please look at your R. Okay. And this is 3. The next one, you need to refer your P. Since our P here is 0.3. So from the table here, 0.3 is here. So the value will be this one. 0.8732. You need to refer to the correct row and the correct column. If not, you will get the wrong answer. Therefore, the answer will be Px greater than or equals to 3 is equals to 0.8732. You can refer your table, binomial table or Poisson table or normal table at the back of your module. Okay students, so that's all for lecture 3 of 5. Thank you.